This project examines a news classification experiment built on the Bisaillon Fake and Real news dataset from Kaggle, / Bisaillon or Fake and Real news dataset. The corpus contains 898 articles published between May 2015 and December 2017, with labels assigned by the file of origin rather than by per-article fact-checking. A classifier that reads only the subject field and the date, with no article text whatsoever, reaches fun of 1 on the held-out test set. That result sets the tone for everything that follows. The goal of this talk is therefore not to celebrate high accuracy. It is to show why a benchmark that looks solved can still be dangerously misleading, and how the workflow was structured to surface that problem rather than hide it. Each subsequent slide builds toward the metadata-only result on slide 6, which is the narrative spine and the ethical centerpiece of the project. A preview of the headline number now keeps the rest of the presentation honest. The business problem is deliberately narrow. The target use case is an editorial screening aid that can rank incoming articles for human review, not an automated moderation gate and not a fact-checking oracle. That distinction matters because the Bisaillon corpus was assembled from 2 source buckets with very different publication pipelines, and any model trained on it inherits those pipeline differences as features. When the output of the system is framed as triage support, a reviewer remains the final judge, and the classifier serves as an ordering mechanism on a queue. When the same output is framed as truth detection, the framing overstates what the evidence can justify and transfers AC accountability onto a model that was never designed to carry it. I chose the screening aid framing because it is the only framing the results actually support. A model that classifies this specific corpus with 99.8% fun on text alone is an informative ranking signal. It is not an arbiter of truth in the wild, and nothing in this corpus can make it one. The raw dataset contains 898 articles, split into 480 mm in N fake GSV and 417 in true GSEV. Corpus-wide class share is 52.3% fake and 47% real, which is close to balance, but not perfectly even. 3 data quality findings shape everything. A further 631 rows have empty body text, leaving nothing beyond title and metadata. The date field parses successfully for only 74.1% of rows, meaning more than 1 article in 4 has unusable temporal information. Temporal coverage where it does parse runs from 2015, 5/1 through 2017, for 31. Weighted heavily to 2017 with 21. The subject field distribution is where the trouble starts. Real side labels cluster in ePolitis News at 11, 272 rows, and World News at 10, 145. Fake side labels cluster in News at 9, 50. Politics at 6, 841. And Left News at 4, 459. The categories do not overlap. That asymmetry is a first warning that the subject field may act as sourceog. The modeling pipeline is scikit-learn throughout. Every variant uses the same SGD classifier paired with a yetfid F vector is array over unigrams and bigrams. Default English stopwords, no stemming, a stratified 80 or 20 train or test split, and random seed, 42. The modeling subset is a balanced 10, 0-row sample that deduplicates down to 965 unique rows after 35 exact duplicates are removed, producing a 1993-row test set. 4 feature configurations were run in sequence to isolate the contribution of each input. A majority class baseline serves as the floor and guards against mistaking a near-balanced split for a model that has. A title-only model establishes what short headline text can do. A title plus body model establishes what full article text can do. 2 further configurations, title plus body plus subject, and metadata only using subject and date, serve strictly as leakage diagnostics and were never intended as deployment candidates. Reported metrics include accuracy, FON, R, OC, and P. Multiple metrics are retained because a single number can hide failure modes that the combination of numbers exposes, and the combination is what makes the leakage story visible. 3 findings from exploratory analysis shape how the model results should be read. Class balance in the modeling subset is 50.2%, fake against 49.8%, real after deduplication, which means the majority baseline barely beats chance, and any observed gain reflects real signal, rather than a lopsided class distribution. Text length differs by component and by class. Title length has a median of 11 words and a mean of 12.45 words. Body length has a median of 362 words overall, with real articles averaging 405.28 words, meaning real articles run noticeably longer than fake articles. Combined title plus body length has a median of 375 words. The length gap explains by adding body text to the title representation as classifier signal. The subject field finding is the most consequential. Real and fake articles occupy almost non-overlapping category labels. A classifier that receives the subject field is not reading articles. It is reading a tag applied at dataset construction. That observation is carried forward into the leakage diagnostics on the next slide. This is the central finding of the project, and it is the reason the presentation exists. A classifier that sees only the subject field and the date, with no article text of any kind, reaches accuracy 1 and F1 on the 993 row held out test set. A second diagnostic that combines title, body, and subject reaches the same perfect score. The metadata only result. The Bisaillon corpus can be classified without any model ever reading a word of journalism, because the subject field is functionally a copy of the class label. That is target leakage in its clearest form. Once leakage of this magnitude is visible, the earlier text-based results must be reinterpreted. The title plus body model reaches F1 0.999 and or OCA U C 0.9999 on text alone, which remains the strongest defensible result in the project. But the perfect metadata score reframes what those numbers mean. They reflect a benchmark that is structurally too easy, not a model that understands truth. My reading is that perfect scores signal the learned coefficients point in the same direction as the leakage diagnostic. On the fake-weighted side, the top terms include image at coefficient 12.38, featured image at 11.82, Getty at 10.76, and watch at 4.62. These are layout conventions and image credit boilerplate from specific syndication pipe. On the real-weighted side, the top terms include Corridor C at coefficient -17.42, Side at -9.89, and Washington Reuters at -9.01. These are wire service beeline fragments that appear in Reuters dispatches as a matter of editorial format. The model has learned source identification, not factual evaluation. A reader would not confuse Reuters' beeline text with a signal of truth, and a model that classifies primarily on such fragments is a Corpus fingerprinter dressed as a news classifier. The title-only variant reaches 0.9 C 12 and ROCA. The numbers are real, but what they measure is provenance, and provenance is not what the project claim is allowed to say. The ethics discussion follows directly from the leakage result, and I want to address it in the first person because the judgment calls are mine to own. I do not believe the metric scores in this project justify a truth detection framing, and I think asserting one would cause harm. The most plausible harm is not a single misclassification. It is the framing transfer that happens when a classifier trained on a specific corpus is described as detecting fake news in general. That framing invites deployment against out-of-distribution content, shifts editorial accountability onto a model that cannot carry it, and legitimizes automated moderation decisions whose failure modes have not been audited. The corpus inherits institutional bias from the source selection used to assemble it, weighted heavily toward United States political coverage between 2015 and 2017, with no non-English content and no non-Western outlets. Human review is therefore mandatory, not optional. The model has a place in a workflow. That place is ranking a queue for a reviewer, with the metadata variance never entering the decision path. My recommendation is to deploy the title text-GZD variant, meaning title plus body text with no metadata features, as a screening aid only. That configuration reaches F10.998 on the 993 row test set and is the strongest result that does not depend on leakage. Any deployment must sit behind a human reviewer and must carry visible documentation of the metadata-only leakage finding, so that downstream operators see why the subject field was excluded. I would also flag 2 specific gaps for future work. The misclassification log. For misclassification, which means case-level error analysis, is not possible. A future iteration should force save every misclassified example regardless of how few there are, because aggregate metrics cannot substitute for worked examples of model failure. The second gap is the lack of cross-corpus validation. Every result reported here lives inside the Bisaillon corpus, and nothing here speaks to how the classifier would behave on articles from 2018 onward or on non-United States outlets. Source-aware splits and a second corpus are the 2 highest value experiments still to run. The full analysis lives in the project repository, including the exploratory notebook, the modeling notebook, the validation outputs, the coefficient tables, and the milestone drafts that preceded this presentation. Anyone who wants to reproduce the workflow can run the notebooks in order against the Kaggle slug, Bisaillon, or Fake and Real news dataset, using seed 42 and the same 10-0-row sampling rule, and should recover the reported metrics within sampling tolerance. The literature review cites Bisaillon 2024, the dataset Xu et al. 2020, and Xu et al. 2017, and Pere Rosa et al. 2018 for stylistic analysis of deceptive text, Pothast et al. 2018 for hyperparty send detection, Joe and Zaffarani 2020 for the broader survey, and Pedregosa et al. 2011 is the highest scoring variants in this project are the ones to be most suspicious of, because a 1-1 for metadata alone is a property of the corpus and not a property of the model. Questions are welcome.